So chain rule is what we call function of function. Function of function. We call this function of function. So this is chain rule. It's also simple. It's just that it involves two derivatives, as in you differentiate twice. How are we going to go about that? If you are given a problem and you see that maybe it's a complicated one, maybe it's long, so the first thing for you to do, you firstly represent the one you have in the bracket to be a single alphabet of your choice. You can use either P, either Q, anything you like you use, it's still going to give you the same result. What are we saying? Let's say they say if y equal to x cubed plus 5 raised to the power of 8, they now said find dy dx. You can see in this one, if it's just like 2, I can expand it two times, right? By saying x squared plus x cubed plus 5, x cubed plus 5. But the power we have here is 8. For me to be expanding it up to 8 times, it's going to take time. So that's why we have what we call chain rule. I hope you are following me, right? So how are you going to go about that? You see how we are going to do it. Let me just explain the details. So if I want to do that, look at the way I will do it. The first step, I will let what I have in the bracket to be a single alphabet. I can say let maybe anything you like, let u equal to x cubed then plus 5. So meaning I let what I have in the bracket to be a single alphabet. So that means if u is equal to what we have in the bracket now, this one will now become y is equal to u raised to the power of 8. I hope you get the concept. Let me come again so that you get that. The first step to be considered in this case, we let what we have in the bracket to be a single alphabet of your choice. You can use either Q, apart from the one you have the y and x, let it to be another one. So I let it to be u, let u is equal to x cubed plus 5. The moment I let this one to be u, that means that we have y is equal to u raised to the power of 8. So now this is u and x, and we have du. I will differentiate the first one, I will differentiate the second one. You can see what I have here is u and x. That's why we have du dx is equal to differential of this as usual. That's going to be 3x squared. I hope you get it because we have done that one earlier. If power come to the front, 3x 3 minus 1, and that is nothing but 3x 3 minus 1. I have 2. Okay. So that's for the differential of constant. That's going to be what? 0. Good. So this is y and u. Now the same thing that we have dy du. You can see dy u, dy du. So this one is going to be 8u raised to the power of 7. I hope you are following, right? Yeah, good. So we have differentiated the first one. You have differentiated the second one. But our target is to find dy dx. So now the first one I have du dx. The second one I have dy du. So what did I need to do for me to get dy dx? I will multiply the first one by the second one, meaning dy dx now is equal to the first result, which is du dx, multiplied by the second result, which is dy over du. So here I will have dy dx is equal to, so our du dx, we have it to be 3x squared multiplied by our dy du, we have it to be 8u raised to the power of 7. You can see I have the first result, I have second result, so I want to multiply them together. So 3 times 8, that's going to be 24x squared, then u raised to the power of u raised to the power of 7. I hope you are following, right? But recall that our u is something. Our u is x cubed plus 5. So let's put it here. So that means here we have 24x squared. So this is my u. My u is x cubed plus 5. So here we have x cubed plus 5 raised to the power of what? Raised to the power of 7. I hope you get the logic, right? Yeah, fine. So, but in case if you see this type of problem in objective text, maybe it's just 1 minute. Instead of you using the long process, we have a short way of doing this using the general formula I used earlier. Look at it. I have y is equal to x cubed plus 5 raised to the power of 8. Let's say I find this type of question in the objective text. So how will I do that? Look at the way I will do it. Dy dx, as usual, the power come forward, 8, then differential of x cubed. You differentiate what we have in the bracket, differential of x cubed, and we have 3x squared. Differential of 5, that's going to be 0. Then you will write the problem itself, and the problem itself is x cubed plus 5, then you subtract 1 from the power. Can you see that? Let me repeat this method again. If the power come forward, as usual, then you differentiate what you have inside the bracket. Differential of x cubed, and we have 3x squared. Differential of 5, we have 0. Then we write the problem itself, which is x cubed plus y. Normally, once the power comes forward, we subtract 1 from the power. You remember that? Yeah, good. So that's why we have x 8 minus 1. So here we have, 3x squared plus 0, and we have 3x squared. 8 times 3, that's going to be 24x squared, then x cubed plus 5 raised to the power of 7. If you compare the result, you can see the two are the same. So this method can be used when you have this type of problem, maybe in objective text, and you don't want to waste your time. You can just apply it and solve that particular problem. So let's see another one. Let's see another question from function of function. Maybe they said, find the derivative of the following. Find the derivative or differentiate the following. Differentiate the following anyhow, and derivative, find the derivative of the following functions. 1, y is equal to 2 over x squared plus 1 raised to the power of 8. Y is equal to root of x cubed plus 2. The second one, the third one, y is equal to, let's say, x cubed plus 7x squared plus 5 raised to the power of 3 over 2. So this is another problem, or let's bring one more. So y is equal to 1 over cube root of x squared plus 3. So let's take a look at this one after the other. We want to use a chain rule, which is a function of functions. So the first one we have, they said y is equal to the first one. They said y is equal to 2 over x squared plus 1 raised to the power of 8. So you can see I told you the first thing we consider, listen to the what we have in the bracket. To be a single alphabet, I can say let u equal to x squared plus 1. I told you earlier you can use anyone apart from the y and x because we have them initially. You can use p, you can use q, you can use r, you can use z, anything, any alphabet of your choice as far as not x and y. So now that means if this one is u now, then this one can become y is equal to 2 over u raised to the power of 8, right? So easily I can change this. This one can be y equal to 2u raised to the power of minus 8. So I will differentiate the first one, and also I will differentiate the second one. So second one we have is y is 2u raised to the power of minus 8. So I will differentiate the first one. At the same time, I will differentiate the second one. So u and x, let me explain this one again. We let what we have in the bracket will be a single alphabet. We use u, let u is equal to x squared plus 1. Then after that, so the moment this one becomes u, then we have y is equal to 2 over u raised to the power of 8. So meaning y is equal to 2u raised to the power of minus 8. So now y is equal to 2u raised to the power of minus 8. I will differentiate the first one. At the same time, I will differentiate the second one. So here we have u and x. That's going to be du all over dx is equal to, this is square. That's going to be 2x. And we know the differential of a constant is going to be 0, right? No, fine. Y and u here, and we have dy over du is equal to, now this one is going to become minus 16u minus 9. I hope you get that, because if you have 2u raised to the power of minus 8, just come forward. Minus 8 times 2u minus 8 minus 1, that is minus 16u, then minus 9. I hope you understand it, right? Yeah, fine. So now dy dx, now to find dy dx, it's going to be the first one times second one, which is du dx multiplied by dy over du. So the first one we have is 2x multiplied by the second one we have is minus 16u raised to the power of minus 9. So here I can pull out the minus. 2 times this, I can have 32x u raised to the power of minus 9. This is negative. You can change it to be minus 32x over u raised to the power of 9. But from here, our u is this. Our u is x squared plus 1. I can just change this one to be minus 32x divided by u, which is x squared plus 1 raised to the power of 9. I hope you are following right. Good. So now let's try the next one. The second question, they said y is equal to root of the second problem. They said y is equal to root of x cubed. Y is equal to root of x cubed plus 2. So the same thing, I will just firstly change this and say let u equal to x cubed plus 2, right? So if y is equal to x cubed plus 2, then this one will now become root of u. You get that? So now I can write this as uy is equal to u raised to the power of half. Oh? So this is y, this is u, this one will be dy du. As usual, the power come forward, 1 over 2u, 1 over 2 minus 1. Then we have dy du is equal to 1 over 2u, 1 over 2 minus 1, and we have minus 1 over 2. You get it right? So now at the same time, we can just change this one to be 1 over 2 multiplied by, when we have u raised to the power of minus 1 over 2 is nothing but 1 over u raised to the power of 1 over 2, which is 1 over 2 root of u. You get that one? Because, if you have u raised to the power of 1 over 2, as I told you earlier, if I have u raised to the power of half, is nothing but root of u, right? So now, then second one here, we have u and x. I can have du dx is equal to differential of x cubed, and we have 3x squared. And differential of constant is going to be 0. So therefore, we can have dy dx is equal to, so that's going to be dy over du. Anyhow you put it, dy over du multiplied by du over dx. So our dy du, we have it to be, that is dy dx is equal to, our dy du, we have it to be 1 over 2 root of u. Our du dx, we have it to be 3x squared. It doesn't matter the one that come forward, the one that come first, either the first one or the second one, but what people most is differentiate the first one, the second one, then you multiply them together. So here we can have this one to be 3x squared over 2 root of u. So from here, our u is x cubed plus 2. So that means here I can have this one to be 3x squared over 2 root of, what is my u? My u is x cubed plus 2. So we have x cubed plus 2. You get that? Yeah, fine. So now let's look at the next questions. Can I just leave that one as exercises? Or we solve it together? Okay. Let's just solve it together. So I will just leave this one as a simple exercise. So look at this one. It's just a packaging. They said y is equal to x cubed plus 7x squared plus 5 raised to the power of 3 over 2. So I will do it the same way. The first step, maybe I should use another alphabet here. Let p equal to this, that's x cubed plus 7x squared plus 5. So now, if that one is p, then that one will become y is equal to p raised to the power of 3 over 2. So I will differentiate the first one and the second one. So that is p and x, and we have the p dx equal to, differential of this, I can have this one to be 3x squared. Differential of this, we have 14x. Differential of 5 is constant, that's going to be 0. So y and p, we have dy dp is equal to, this is 3 over 2p, then 3 over 2 minus 1. So here we can have dy dp is equal to 3 over 2p, 3 over 2 minus 1. As same is 2. That's 3 minus 2, that's 1 over 2. Even I can write this one as 3 over 2. If you have p to the power of half, it's nothing but root p. So now, therefore, dy dx is going to be the first one, times the second one, which is anyhow we put it, maybe the y over dp multiplied by dp over dx. So now the y dp we have here is what's the y dp? The y dp is 3 over 2 root of p multiplied by dp ds. We have it to be 3x squared plus 14x. So this multiply this. Down here we have 3 over 2 3x squared plus 14x, then root of p. But from here we know p is x cubed plus 7x squared plus 5. I'll just make a simple substitutions. That's going to be 3 over 2 x squared 3x squared plus 14x. Then root of our p now is x cubed plus 7x squared plus 5. So that's all about that. So this one too, you can just do the same process. If I want to do this one, I will just let, I can write the let u to be this, then I will leave it u raised to the power of 1 over 3, because we have cube root. Then if you want to change that, we have u raised to the power of -1 over 3, and you differentiate that. You get that right?